So this is the first in a series of videos on how to use different programs to view molecular structures. And the first program we're going to be looking at is PyMol, which is up on the screen in front of you. And its user interface is made up of three different windows. The first window is this big long window at the top of the screen, which is called the External Graphical User Interface, or GUI window. And at the bottom of the GUI window, we have this command line where you can enter in text commands to talk directly with PyMol. The second window is this big black window here, where the molecular structure will actually show up and where we'll be interacting with the structure and rotating it and zooming in and out and things like that. And the last window is this long window here on the right-hand side, where our loaded structure, as well as any other objects that we make during the session, will show up. So all of the solved protein structures to date are deposited in a data bank known as the protein data bank. And the nice thing about PyMol is that it connects directly with that data bank, and we can access the structures we need by using their 4-character accession codes or handles. So the structure that we're going to be looking at today is antitrypsin, and we can get that structure directly from the protein data bank, or PDB, using the simple fetch command in PyMol's command line. So we type in fetch and the 4-letter accession code for antitrypsin, which is 3CWM, press enter, and there's our structure. So right now it's shown in what's known as line representation, with the nitrogen atoms in blue, the oxygen atoms in red, and all those carbon atoms in green. But that's a little hard to look at, so we can change the representation, as it's called, to make it a little easier by going to this object control panel on the right, and we can see our structure is loaded here. So to change the representation, we go to show and pick cartoon, which is a much nicer representation to look at. So all the alpha helices are in these lovely coils, and then you can see a beta sheet down here, but the line representations are still shown. So to hide those, we go to the object control panel again, and this H submenu, which is next to the S or show submenu, click on the H or hide submenu and say hide lines, and the lines are gone. So this is great if you want to get an overall view of the protein or structure that you're looking at, but a lot of the times you want to zoom in on a few residues to see how they're interacting with each other. And an easy way to do that is by using the sequence bar. We make the sequence bar visible by going to the bottom of the object control panel and clicking this S button here. So this brings up this sequence, the primary sequence of the protein in the 1-letter amino acid codes. So this molecule that we're looking at, this antitrypsin protein, is a special structure because it has a citrate molecule non-covalently bound to it. So we want to see how that citrate molecule interacts with the residues closest to it. So in order to do that, we can select the citrate molecule by clicking on it in the sequence bar, and then also selecting the residues nearest it. So going backwards now, we want arginine 281, which is right here. And you'll want to note that for residue numbers that are more than 1 digit, the amino acid that the number is referring to will be directly below the first or leftmost digit. So there's arginine 281 selected. We also want lysine 243, so it's 1, 2, 3. Here it is. And lastly, we want arginine 196. There it is. So you may have noticed that as we were selecting these residues, this new object, denoted by SELE, has appeared in the object control panel. Now we don't want to leave the name as it is, because otherwise the next time we select a different set of residues, this selection will be overwritten. So to avoid that, we're going to change the name of this selection by going to the A or Action submenu, go down to Rename Selection, and now we can just enter our name of choice. We can say maybe RRK sit, press enter, and now this is renamed effectively. So in order to get a closer look at our residues, what we can do is go again to the Action submenu of our RRK sit selection and say zoom. And that doesn't really help us much though, because we don't see the side chains and we don't see the citrate. So to change that, we again change the representation just of the selection by going to the show menu, say show as sticks, and we can see the different amino acids and the citrate molecule here. So it would be better if we can hide the cartoon structure, which we can definitely do by going to either the all submenu or the structures submenu, the hide submenu, and saying hide cartoons, and there's our selection jumping out at us. But it would be great if we could make this a little easier to look at. So in order to do that, we can use the different mouse buttons on a 3-button mouse. The rightmost mouse button zooms in and out, so it zooms in when you pull the mouse towards you, it zooms out when you push the mouse away from you, and the middle button translates the structure across the viewing window, and the leftmost mouse button rotates the selection. So let's just rotate this so that we can actually see the citrate molecule pretty well. And you may have noticed that there are no hydrogens on the amino acids or the citrate. That's because when the structure is solved of this or any other protein, typically the hydrogens are too small to resolve in the structure. But PyMol can add them with a pretty good idea of where they are. So in order to do that, we go to the all selection in the object control panel, go to Action, and the hydrogens option, say add, and that shows us the hydrogens that we want. Now it might be a little difficult to distinguish the citrate among the 3 amino acids. So what we can do to change that is change the color of the citrate by making a new selection with just the citrate. And to do that, you can either click on it in the molecular viewing window, or that's the same thing as clicking on it in the sequence bar up here. And that's given us a new selection that we can then rename as something sit only. And to change the color of the selection, you go to the sit only selection and the C button on the right, and you can either color all the atoms in the selection the same color, but for our purposes it might be more useful if we color by element, where effectively the colors of all the other elements stay the same, but you can change the color of the carbon atom. So let's change the color of the carbon atom to a cyan. That'll make the citrate easier to see. And now that the hydrogens are in place, we can kind of see that there are some potential hydrogen bonding interactions, but it's not completely obvious. So one thing we can do to clarify that for ourselves is to measure the distances between specific atoms. And to do that, you go to the wizard menu up here, and go to measurement, and on the left hand side of the viewing window, PyMol will give you a nice helpful prompt about which atom to click on. So first let's measure the distance between this primary nitrogen of this lysine residue up here and this oxygen of the citrate molecule. So we'll just pick one of the hydrogens as our first atom, then click the oxygen. We can see that that's actually pretty far away. I mean, in depending on how you rotate the molecule, it looks like maybe it would be hydrogen bonding, but not so much. So then we'll try the this hydrogen connected to this nitrogen of the lysine residue here. Make that again our first atom and see its distance to the same oxygen. You can see that that's much closer, and that's definitely hydrogen bonding. And maybe we can also try the distance between this oxygen atom here and the hydrogen atom on what looks like the backbone amide nitrogen, which is also within hydrogen bonding distance, but weaker than the previous bond we measured. So those are some really useful things that can be done with PyMol.